Okay, guys, in this example, we're going to take a look at also simple linear regression where X is the price of a printer and Y is the demand. In other words, how many printers we can sell at that price. All right, so let's go ahead and open up Desmos. Let me copy paste the data into Desmos so we can start analyzing it. And then after we do that, we are going to click on this icon here that says linear regression. Okay, so it looks like the relationship here is going to be negative. We can see that the line slopes downward, right? If you go from left to right. Okay, so the first thing to do is go ahead and export a snapshot to the expression list. So we've got that. We already have the equation. And we would type this over here, except we do need to round to 3 decimal places. So let's go ahead and round the slope. Notice how the slope here is negative. So that goes in here. Don't forget the x because it's an equation. Plus, okay, so now let's do the y-intercept. Let's round that to 3 decimal places. So that would be that. Okay, so now let me just submit to make sure I got this right. Okay, now in terms of the interpretation of the slope and the intercept. So for the slope, we're gonna say if x increases by 1, then y is predicted to either increase or decrease by, and then we put absolute value of the slope. Okay, so what is that going to sound like for us? So instead of x, you are going to put the label of the x variable, right? And instead of y, you're going to put the label of the y variable, which is the demand. So instead of x, you're going to say if the price increases by 1, I'm assuming dollar, then y, which is the demand, that's how many items you can sell, is predicted to, now here I'm going to say decrease. And the reason why I'm saying decrease is because I can see that the slope is negative, and I could also see the relationship is negative. I can also, by the way, see that the correlation, which is R, that's negative. So that is another indication, of course, that there should be decrease. And you do not put the negative in the interpretation. That's not okay. So that would be this. So let's just say approximately 0.3. So if you increase the price by $1, then you will expect on average to sell about 1/3 less of a printer. Or you can multiply this by 3 and say if you increase the price by $3, then the demand will decrease by 1, right? Approximately. Anyway, so let's go to the correct interpretation. So if the price increases by $1, the demand is predicted to decrease by 0.3. Okay. Now, in terms of the intercept, for the intercept, we are going to say if x is 0, then y is predicted to be, and then whatever is the intercept. So for me here, I would say if the price is 0, then y, which is the demand, is predicted to be, well, what's the intercept? Well, that would be 42 approximately. So 42.7, I don't know, 42.8 approximately. Okay, now that would actually be incorrect. That would be incorrect. And maybe there is an option that says something like that. It looks like that's this one, but that is wrong. Why is this wrong? Because when you look at the price, you need to ask yourself, when you're saying if the price is 0, does that include any of the prices that you see here? Do you see a price of 0? Well, first of all, nobody's going to sell you a printer for $0. Right? So that's not going to happen. But also the range here of X values is from 70 to 100. They do not include 0. So price of 0 is outside the scope of the model. Interpretation of the intercept is not appropriate. So we should say interpretation is not appropriate because the price of 0 is outside the scope of the model. Notice how there are two options and both of them say not appropriate. Well, one of them says demand of 0 and the other one says the price of 0. So always remember, it's always about the x being 0, whether it's in the experimental region or not. And x again was what? Well, x was the price. So it's all about the price of 0 not being there. Okay, not about the y. All right, now let's go ahead and do the predictions. So to do the predictions, we just replace the x value with parentheses, and whatever x value we see, we put it in parentheses. Now we do want to round this to 1 decimal place, and then let's also gonna do the same thing for 80. So that would be 16.5. Now, here is the problem. The problem is that one of these is going to be D and E. It does not exist. And actually, it does exist. It's not like you cannot plug it in. You can. The problem is it valid? Is it appropriate? Do you see anything like that in the data that would support this kind of prediction? So you have to go and look at your data, okay? So I can see my data, again, ranged from 70 to 100. So if a value is in this range, then it is okay. But if it's outside, it's not okay to do the what we call extrapolation. So 80 was between 70 and 100, but 61 was not. So this will actually be D and E there.